Welcome pre-Cal students to the homework help video, page 850, 19 through 27 odd, page 300, and also numbers 33 through 49, every other odd. Have your books open to page 850, have your homework out, and let's go ahead and get started. Let's take a look first of all at numbers 19 through 27 odd. The directions say, predict the general term or nth term of the sequence. Answers may vary, and it is true that sometimes you will get more than one answer. There's more than one possible answer. So, all right, here we go. Let's go ahead and get started here. On this problem here, what I've encouraged you to do is, first of all, always write the number of the term above each number. Second of all, I've always encouraged you to then try to look for a pattern. For example, here we're adding 2 over and over and over. Or in other words, we're taking our first term, which is 2, and we're multiplying it by a number. 2 times 2 for 6. For 6, we could say 2 times 3. For 8, we could say 2 times 4. For 10, we could say 2 times 5. See that pattern? And for 2 right here, I could say 2 times 1. So I found my pattern. The first term is 2 times 1, the second term is 2 times 2, the third term is 2 times 3, etc. Notice the numbers inside the parentheses match the term that it corresponds with, okay? And then notice every single term has a 2 in front. So really, it shouldn't be too difficult to write the nth term. It would simply be a subscript n equals, and then we know every term would have a 2 with it. And then notice how the term number 1 matches the number in the parentheses, so I can put an n right here, and that's the nth term. So in other words, 2 times 1 would give me 2. For the second term, I would put a 2 right here. 2 times 2 gives me 4. For the third term, I would put a 3 right here. 2 times 3 is 6. For the fourth term, I would put a 4 right here, and 2 times 4 is 8. So there is my nth term. That one's not too difficult. Let's take a look now at number 21. All right, number 21 is going to be a little more difficult. First of all, let's go ahead and do our usual steps. This is my first term, this is my second term, this is my third term, and this is my fourth term. Also, students, notice I have my alternating sign sequence where it's negative then positive, negative then positive. And remember what I taught you. We can ignore those signs for now, and then a little bit later we can put this in front of our nth term. So we'll talk about that later, but ignore the signs. Okay, let's look for a pattern. Looks like I'm multiplying by 3. 2 times 3, 6 times 3, 18 times 3. So I'm multiplying by 3 all the way across. So whenever that happens, just like the last problem, we were multiplying by 2. So we took our first term and we put our first term right here, like that. Well, it's going to be the same thing again if I'm multiplying by a set number. Now, forget the negative signs. Don't worry about that. I'm going to put 2 times 1 for my first term, and then I'm going to keep bringing that 2 over because 2 is my first term, and I'm multiplying by the same number over and over, which is 3. So 2 times 3, and then 2 times 9, and then 2 times 27. Now, I still haven't found much of a pattern here, but I noticed this about the 3, 9, and the 27. For the 3, I could really put 3 squared. And for the 9, I could really, or I'm sorry, that's wrong, I apologize. For the 3, I could put 3 to the 1. And for the 9, I could put 3 squared. And for the 27, I could put 3 to the third. So now I'm getting a pretty good pattern. And again, I know you're thinking, I would have never thought to have done this, Mr. Hart. I know that, but it takes practice. Now for the 1 right here, don't forget that anything to the 0 power is 1. So really for the 1 right here, I could put 3 to the what power? 0 power. So 3 to the 0 power is 1, 3 to the 1 power is 3, 3 squared is 9, and 3 cubed is 27. Now the reason I did that is I'm trying to find a nice pattern. Now do you notice something about all these terms? They all have a 2. Do you see that? They all have a 2. So for my nth term, I know I'm going to put a 2. They all have a 3, so I know I'm going to put a 3. And then notice this. It's 0, 1, 2, 3. Now see how I have a 0 here, but it's for the first term. And I have a 1 here, but it's for the second term. I have a 2 here, but it's for the third term. I have a 3 here, but it's for the fourth term. So do you see how all of these numbers down here are 1 less than the term that it is? This is the first term, but I have a 0, 1 less. This is the second term, but I have a 1, that's 1 less. So because all of these are 1 less, I'm going to put n minus 1, 1 less. Let's see if this works, okay? Let's put a 1 in. 1 minus 1 is 0, 3 to the 0 power is 1, and 1 times 2 is 2. 2. Let's put a 2 in. 2 minus 1 is 1, 3 to the 1 power is 3, 3 times 2 is 6. 6. Let's put a 3 in. 3 minus 1 is 2. 3 squared is 9. 9 times 2 is 18. So this works. The only thing we got to do now is we got to remember the signs are alternating, negative, positive, negative, positive. And so we're going to have to put this in front of my nth term. And there's your nth term. I warned you guys these are not easy, okay? We're going to have to really, really work on these, but they're good. They're good practice. Okay, let's take a look at number 23. Now, first of all, let's go ahead and put our term numbers up top like I've taught you to do. 1, 2, 3, 4, and 5. Now next, guys, I want to be honest with you. This really, I'm not even going to look for any adding or subtracting or anything. You're not Mr. Earhart? No. Look at this, guys. Notice how the numerators go 2, 3, 4, 5, 6. And notice how the denominators go 3, 4, 5, 6, 7. So just use common sense. For my nth term, do you see how all of these top numbers are 1 more than the term? The term is 1, but I have a 2. The term is 2, but I have a 3. The term is 3, but I have a 4. All of these numbers are 1 higher than the actual term. So I'm just going to put n plus 1 for my numerator. Now look at your denominator. Do you see how 3 is 2 more than 1? 4 is 2 more than 2. 5 is 2 more than 3. 6 is 2 more than 4. 7 is 2 more than 5. So all of the denominators are 2 more than the actual term. So I can put for my denominator n plus 2. And we're done. Let's see if it works. Put a 1 in for n. You would get 2 over 3, 2/3. Put a 2 in for n. You would get 3/4, 3/4. Put a 3 in for n. You would get 4/5, 4/5. Put a 4 in for n. You would get 5/6, 5/6. So this is your answer. I think it looked a lot harder than it actually was, or in other words, the bark was worse than the bite, but that's all you have to do on that one, okay? So pretty simple. Okay, let's continue on and take a look now at number 25. Okay, now in 25 here, they've kind of helped you out. If you can imagine, if they just would have given you 2, 6, 12, and 20, that would have been a pretty difficult nth term to figure, because you're adding 4, then you're adding 6, then you're adding 8, and that would have been pretty difficult. So they actually set you up pretty nicely here. Notice basically what they have. Well, first of all, let's write our term numbers. That's term number 1, term number 2. By the way, how do I know where a term is? These commas. Commas always separate terms. So first term, second term, third term, fourth term. So basically you have 1 parentheses 2, 2 parentheses 3, 3 parentheses 4, and 4 parentheses 5. Okay? Now, can I show you something? Notice how the outside numbers go 1, 2, 3, 4. And notice how there's a 1 here and a first term here, a 2 here and a 2 here, a 3 here and a 3 here, and a 4 here and a 4 here. So because of that, that tells me right away I'm going to have an n. And now inside the parentheses here, notice I have 2, 3, 4, 5. Now notice how 2 is 1 higher than 1, 3 is 1 higher than 2, 4 is 1 higher than 3, and 5 is 1 higher than 4. Do you see that? So all the numbers inside the parentheses are 1 more than the actual term that it is. So I'm simply going to put n plus 1 inside the parentheses. There we go. Let's check and see if we're right. Put a 1 in and you will get 1 times 2, which is good. Put a 2 in, you'll get 2 times 3, which is good. Put a 3 in, you'll get 3 times 4, which is good. Put a 4 in, and you'll get 4 times 5, which is good. So this nth term works perfectly. Let's take a look now at the next problem, number 27. It's kind of funny. 27 looks really scary, but it's actually pretty simple. I mean, when you stop and think about it for a second. First of all, let's go ahead and write the term numbers up top. First term, second term, third term, and fourth term. And then if you'll look at, let's just leave 0 alone for a second. We're trying to find a pattern. And I think I see the pattern. I mean, it's log of 10 to the what power, 1. Log of 10 to the what power, second. Log of 10 to the what power, third. So over here, I'm kind of thinking, hold on, I have a 0 right here. But if you'll think about this for a second, just trust me. If I put log of 10 to the 0 power, that would fit really nice, wouldn't it? Log of 10 to the 0, log of 10 to the 1, log of 10 to the 2, log of 10 to the 3. The only thing is, students, does this logarithm right here equal 0? Well, the answer is yes. Anything to the 0 power is 1, 10 to the 0 power. So log of 10 to the 0 power really just means log of 1, and the log of 1 is 0. Use your calculator if you want to and test me on that, and you'll see it does equal 0. So we're looking pretty good here. I drew a nice pattern up, and notice that this power here, notice all of them have a log of 10. All of them have a log of 10, so I know my nth term is going to be log 10. And then notice this 0 is 1 less than 1. This number is 1 less than 2. This power is 1 less than 3. And this power is 1 less than 4. So all of your powers, your exponents, are 1 less than the actual term. So my power right here is just simply going to be n minus 1. And that's it. You did it. A subscript n equals this right here. And test it and see. If you put a 1 in, you'll get log 10 to the 0 power. Put a 2 in, you'll get log 10 to the 1 power. Put a 3 in, you'll get log of 10 to the second power. Put a 3 in, you'll get log of 10 to the or put a 4 in, you'll get log of 10 to the third power. So it works fine. You know, students, let me grab a quick drink here. You know, you're just going to have to practice these. There's no set way to do it. I've given you some suggestions how you always write the number of the terms across the top and then try to find a pattern and stuff like that. But other than that, you're just going to have to practice, okay? All right, the next 5 problems are a little long, and I'll try to go as fast as I can. However, they're not difficult, okay? So number 33, we're going to put a 1 in for k, and then a 2, then a 3, then a 4, all the way up to 5. So 1 over 2k, I'm going to put a 1, and then plus 1 over 2 times 2, plus 1 over 2k, I'm going to put a 3, plus 1 over 2k, I'm going to put a 4, and then 1 over 2k, I'm going to put a 5, all right? And then 2 times 1 is 2, 2 times 2 would be 4, 2 times 3 would be 6, 2 times 4 would be 8, and 2 times 5 would be 10. Now, because all of these fractions have different denominators, it's going to take a while to find a common denominator. I would encourage you to use your calculator and just simply type in 1/2 plus 1/4 plus 1/6 plus 1/8 plus a 10th, and you'll get out a decimal. Then for you graphing calculator students, if you hit math, enter, enter, you'll get this out right here. And for those that don't have a graphing calculator, when you enter all of these fractions, be sure and use your fraction button, your ABC button, and you should get this out right here. Or it might say this. For some of you, it might say 1 and 17 over 120. That's the exact same thing. All right, let's take a look now at number 37. All right, for number 37, we're taking the natural log of k. We're starting with 7 and we're going to 10. So natural log of k, which is 7, plus natural log of k, so I'll put an 8, plus natural log of k, I'm going to put a 9, plus natural log of k, I'm going to put a 10. Now with your graphing calculator, I would just type the whole thing in at once. I would hit natural log of 7, be sure and close the parentheses, plus natural log of 8, be sure and close the parentheses, plus natural log of 9, be sure and close the parentheses, and then plus natural log of 10, be sure and close the parentheses. If you'll hit enter on that, you will come up with an answer approximately like this: 8.525161361. You can round to wherever you want to. Now, those that have a graphing calculator, you'll find the natural log button. Here's your graphing calculator. If you'll look at the first column here, and then go down to the bottom and count up 3 buttons. 1, 2, 3. Right here, you'll find a button that says this: LN. That's your natural log button. For those that don't have a graphing calculator, you're going to have to look for a button that says capital L, capital N, or it might say little l, little n like this. I'm not sure, but look for a button like that, and that is the button you would want to use. Okay, let's continue on. Take a look at number 41. Excuse me. Okay, we're going to start with 1 and go up to 5. So I have -1 to the I power, so I put a 1, plus negative, plus I have, hold on, my mimeopad's freezing up here, plus I would then have -1. Yeah, it's doing some weird things here, folks. Hold on one second. Then I would put -1 to the I power, and so that would be a 2, plus -1 to the I power. I'm not sure why it's doing that, so please bear with me. That would be a 3, plus -1 to the I power, so I'd put a 4, and then plus -1 to the I power, that'd be a 5. Now, -1 to an odd exponent is -1. -1 to an even exponent is +1, so +1. -1 to the third power would be plus a -1. -1 to the fourth power would be a +1, and -1 to the fifth power would be a -1. So here we go. We have a -1, a -1, and a -1. That's a -3. We have a +1 and a +1. That's a +2. And then combine those, you get a -1. If you just wanted to take your calculator and simply type -1 plus 1 plus a -1 plus 1 plus a -1, either way, you will get out -1 for your answer. All right, let's take a look now at number 45. We're going to put in 0 and go up to 6. So I have 2 over k squared, so I put a 0, plus 2 over k squared, so I'll put a 1, plus 2 over k squared, so that would be 2 squared plus 1, plus 2 over k squared, that's 3 squared plus 1, plus 2 over k squared, that would be 4 squared plus 1, plus 2 over k squared, that would be 5 squared plus 1, plus 2 over k squared, that'd be 6 squared plus 1. So, real quick here, 0 squared is 0, plus 1 is 1, so 2 over 1 is 2, plus 1 squared is 1, plus 1 is 2, so 2 over 2 is 1, plus 2 squared is 4, plus 1 is 5, so 2/5, plus 3 squared is 9, plus 1 is 10, so 2/10, plus 4 squared is 1 is 16, plus 1 is 17, so 2 over 17, plus 5 squared is 25, plus 1 is 26, so 2 over 26, plus 6 squared is 36, plus 1 is 37, so 2 over 37. Now, I'm going to quickly grab my calculator and type all of this in. That's the best way to do it. And by the way, I know I could reduce 2/10 and I know I could reduce 2/16, but since I'm going to type the whole thing in and get out a fraction anyways, that's not really a big deal to me. I don't think you're saving a lot of time by reducing. Let me check this real quick. 2 plus 1 plus 2 fifths plus 2 tenths plus 2 17ths plus 2 26 plus 2 2 tenths plus 2 17ths plus 2 26 sevenths, and I'm getting out, I hope I did this correctly, it's not giving me a fraction for some reason when I hit math enter. So some fractions are so big it won't do that for you. So in this case I would let you have a decimal. Now if yours is giving you a fraction, that's fine, but 3.8486, and I kind of left it there. I rounded that, but you can round wherever you want to. So there we go. All right, and last one, and we're finally done. So time for cheers on that one. Here we go. Oh, they went 0 to 10, didn't they? That's really kind of ridiculous, but okay, fine, whatever. Here we go. Everywhere there's a 1, we're going to put a 0 and then a 10. So we're going to need a lot of room for this one. So here we go. We're going to have, I have to write really small, 2 to the 0, 2 to the 0 plus 1 plus 2 to the 1, 2 to the 1 plus 1 plus 2 squared, 2 squared plus 1 plus 2 cubed, 2 cubed plus 1 plus 2 to the 4th, 2 to the 4th plus 1 plus 2 to the 5th, 2 to the 5th plus 1 plus 2 to the 6th over 2 to the 6th plus 1 plus 2 to the 7th, 2 to the 7th plus 1 plus 2 to the 8th over 2 to the 8th plus 1. I'm not a fan of this problem. If I would have seen it, I probably wouldn't have given it to you if I would have noticed this. It's just like busy work to me, but that's fine. I think one thing they might be testing you on is to make sure you don't do this. Some students would look at this and say, oh, 2 to the 0, 2 to the 0, cross them off. 2 to the 1, 2 to the 1, and cross them off. 2 squared, cross them off. And you cannot do that. You cannot, because there's 2 terms in the bottom. So that might be one reason they gave this to you. Okay, here we go. Here's our first fraction. Anything to the 0 power is 1. So this is 1. 1 plus 1 is 2. So I have 1/2 plus 2 to the 1 is 2. 2 to the 1 is 2. 2 plus 1 is 3. So 2/3. I'm going to cross these off as I do each one. All right, 2 squared is 4. 4 plus 1 is 5, so 4/5. 2 to the 3rd is 8, so this would be 8/9. 2 to the 4th is 16, so it would be 16/17. Next one, if you simplify it correctly, would be 32/33. The next one would be 64/65. The next one would be 128/129 plus, let's see, 256/257. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the next one would be 512/513, because the very last one here, 2 to the 10th power is 512. So, and actually it looks like I'm off by 1, which is very frustrating, and I apologize. Last thing I want to do is mess this up. 2 to the 3rd, 2 to the 4th, 2 to the so hold on one second. I hope I've not messed this up. 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th. Oh, this is 2 to the 9th. 1, 2, 3, 4, 5, 6, 7. We have one more fraction to go. I apologize. Okay, and the last one is 1024/1025. I really believe in being a hardworking teacher. I really don't see a huge need to type all this in. I would not give you one of these on a test or a quiz. If you want to type this in and hit math enter, and then look in the back of your book and see what the answer is. That's fine. Again, I mean, this is really, I wouldn't have given you this problem if I would have realized what they're asking you to do. It's a fine problem, nothing wrong with it, but it is a lot of busy work. And at this point in time right here, I know that you know how to type all this into your calculator. Okay, so you go and finish if you want to, or you can stop right there. That's totally acceptable. I hope this homework help video has been a help to you. Please call or email if you have any questions at all.